In this video, we will learn about virtual memory concept and implementation by demand paging in operating system. My name is Prabhat Kumar Ahirwar, CS3, Acropolis Institute of Technology and Research, Indore.
Modern operating systems use virtual memory to provide an abstraction that simplify memory management and improve system efficiency. Virtual memory allows processes to execute even if their complete memory requirements are not loaded into the main memory.
So, first we learn about memory management. What is memory management? A memory management is fundamental function of an operating system that handle or manage primary memory RAM. It keeps track of each bit in a computer's memory and allocates or deallocates memory block as needed by programming during execution. Memory management is very crucial for program execution. Also, limited resources must be managed efficiently. Basic memory management issues. First, allocation and deallocation of memory. Second, protection of memory areas. Third, sharing of memory among processes.
Now, we will learn about virtual memory. What is virtual memory? Virtual memory is a storage scheme that provides users an illusion of having a very big main memory. This is done by treating a part of secondary memory as the main memory. User can load the bigger size processes than the available main memory by having the illusion that the memory is available to load the process. Instead of loading one big process in the main memory, the operating system loads the different part of memory than one process in the main memory. Virtual memory is implemented using demand paging or demand segmentation. Key features of virtual memories: illusion of large memory to processes. Logical address space is separated from physical address space. Enables multiprogramming and efficient process isolation. Discuss why use virtual memory. To execute large applications that do not fit into physical memory. To improve CPU utilization through multiprogramming. To ensure memory protection and process isolation. To simplify programming by removing the need for manual memory allocation. Concept of paging. There are pages and frames. Virtual address space is divided into pages. Example 4 KB. Physical memory is divided into frames. Same size as page means the size of page and the size of frame are same. It also address translation basic. Logical address means page number and offset is translated to physical address, frame number, offset using a page table. Means logical address is translated into physical address by using page number and frame number, also by using page table. Discuss about address translation. Virtual addresses used by programs are translated to physical addresses using a component called the Memory Management Unit (MMU). Translation components are page table maps virtual pages to physical frames. Second, TLB translation look-aside buffer cache for recent address translation. Now, we will see what is demand paging. Demand paging is a memory management technique where Pages of a process are not loaded into main memory until they are actually needed, means on demand during the execution. There are actually needed of page, the main memory will load it during the execution. It is a type of virtual memory management. Instead of loading the entire process into RAM, only required pages are loaded. If a page is needed but not present in memory, it triggers a page fault and the OS loads it from secondary storage into the RAM. There are some characteristics. Pages are not loaded at the start of the program. Pages are fetched on demand during execution. If a required page is not in memory, a page default occurs. Steps in demand paging. Page fault occur when a page is referenced but not in memory. Page table is checked to verify validity and location of the page. Page is loaded from disk into a free frame. Instruction that caused the page fault is restart. Now we will discuss a flowchart how page fault handling process work. Firstly, it will start page access. If the page is available in memory, then it will continue. If it is not available, so it will be page fault. Then it will find free frame. Now load page from disk and update the page table. It will restart faulting instruction and then continue. Let's discuss page fault handling in detail. First, page access. Page not found in memory. OS trap control is transferred to the operating system. Third, find free frame. OS looks for a free frame in physical memory. Fourth, swipe in page. The page is loaded from the disk to RAM. Fifth, update page table. Mapping is updated. Sixth, restart instruction. The instruction is re executed. This is all about how page fault works. Now we will discuss about advantages of demand paging. First, efficient memory use. It only required pages are loaded. Second, faster startup. Program load fast since not all pages are loaded initially. Third, support large programs. Executes programs larger than RAM size. Now discuss some disadvantages of demand paging. First, page fault overhead. Each fault incurs performance cost. Second, thrashing risk. Too many page faults lead to low CPU utilization. Third, disk dependency. Slower if disk input output is not optimized. Now we will discuss about thrashing in demand paging. Thrashing occurs when the system spends more time servicing page faults than executing processes. It usually happens when too many processes are loaded in memory with insufficient frames. There are some solution techniques. First, use of working set model. Second, implementing page replacement algorithm. Third, load control. Reduce number of processes. Now, there are some page replacement algorithms. When no free frames are available, the OS must decide which page to replace. Common algorithms are FIFO, first in, first out, LRU, least recently used, optimal page replacement, Now, we will conclude our topic virtual memory and demand paging. Virtual memory and demand paging significantly enhance system flexibility and efficiency. By decoupling logical and physical memory, they allow for execution of large application, efficient process management, and improve overall system performance. However, optimal performance depend on proper configuration and efficient page replacement strategies. Virtual memory with demand paging is a powerful technique for efficient memory management. It always running large programs support multitasking and improve memory utilization. Thank you.